Okay, Assalamualaikum warahmatullahi wabarakatuh. Let's continue our lecture on fresh concrete. The second part will be on the problems and testing of fresh concrete. Okay, so problems in fresh concrete, as we learned before, there is segregation and also bleeding of fresh concrete. So what is segregation? Basically, segregation is defined as the separation of the materials of fresh concrete. If we are going to produce a good concrete, the all ingredients should be properly distributed to make an homogeneous mixture. There are considerably differences in size and also the specific gravity of the ingredients in concretes. Therefore, they have a tendency to fall apart. So we have to make sure the well-made concrete must be take into consideration of these various parameters such as the grading, the size, the shape, the surface of the texture of aggregate with optimal quantity of water so that we can get the cohesive mixture. Cohesive and also the fatty characteristics of the mix do not allow the aggregate to fall apart. At the same time, the matrix itself is sufficiently contained by the aggregate. Similarly, water also does not find it easy to move out freely if we have well-made concrete, which is a very cohesive mixture. Segregation may be of three types. It can be the coarse aggregate separating out of or settling down of the paste, or the paste inside separating away from the coarse aggregate, and also water separating out from the rest of the material. Okay, so these are the three types of segregation problems. Okay, so this is example of segregation. So here is the fresh concrete. We can see here the coarse aggregate clearly, and when it hardened, we can see here there is a aggregate on top of the concrete, and it may lead to some cracking. Okay, so what are the conditions favorable for segregation to be happen? So the first one is when we have badly proportioned mix, where the sufficient matrix is not there to bind or contain the aggregates. Insufficiently mixed concrete with excess water content, so means we have more water in our mix, then segregation may happen. Conveyance of concrete by conveyor belts, wheelbarrow, or long distance haul by dumper, or long lift by skip and hoist, and the other situation that promoting segregation of the concrete. So this one is during transportation of the fresh concrete, it may happen that our concrete may be segregated. When concrete is discharged from a badly designed mixer, and also dropping of concrete from height, for example, during transportation or placing of concrete. Okay, so these are the conditions where we can have segregation happen in our fresh concrete. The second problem is the bleeding. Bleeding means water gain. Water, particularly from segregation, in which some of the water from the concrete comes up to the surface of the concrete. Predominantly observed in highly wet mix, which is the bleeding normally occur when we have excess of water, more water in our mix, and it badly proportioned, and also insufficiently mixed concrete. In thin member like a roof slab or road slab, and when concrete is placed in sunny weather, will show excessive bleeding. Okay, so this is some example of bleeding in concrete. You can see here there is some water contained on the top of our concrete. Okay, so how do we prevent bleeding? The first one is must be proportionate mix design. Okay, and then we can use finely divided pozzolanic materials, which can reduce bleeding by creating a longer path for the water to traverse. And also we use finer cement or cement with low alkali content, which is the rich mix are less susceptible to bleeding than lean mix. Means when we use finer cement, we have a rich mix, more paste, so that it can reduce bleeding. And also we can add some admixture, which is air and cleaning agent, to reduce the bleeding. Okay, so now we are going into the testing of fresh concrete. The first testing is on the slump test, which is we need to check the workability of our fresh concrete. You can refer to this video on how is it going to be conducted on slump test. Okay, so the slump test is a means of assessing the consistency of the fresh concrete, and it used indirectly as mean you checking the correct amount of water has been added to the mix. Okay, so these are the procedure of slump test. The first one is the steel slump cone is placed and we fill with fresh concrete by 3 layers, and then each layer we compact it or we roll it for 45 times, and until the third layer we finish off the level on top of the cone, and then we lift the cone carefully and see how the concrete settles. Okay, and then we measure the settlement. When the cone is removed, the slump may take one of these 3 forms: true slump, shear slump, or collapse slump. Okay, so true slump means when we have a cohesive or rich mix, which the slump is generally sensitive to vibration in workability. Okay, so it's very smooth slump. And then we have shear slump. It occurs more often in linear mix than the rich one, which is indicate that we have a lack of cohesion associated with a harsh mix. And also the third one is collapse slump, is usually for very wet mix, indicative that very poor quality of concrete, and most frequently result from the segregation of its materials. Okay, the second test is compacting factor test. Okay, this is the apparatus that we are going to use, and you can refer this link to see how we conduct the compacting factor test. Compacting factor test is to measure the degree of compaction. The test requires measurement of the weight of partially and fully compacted concrete. The ratio between the partially compacted weight to fully compacted weight must be always less than 1 and is known as compacting factor. For normal range is between 0.8 to 0.92, and basically for drier mixes. And this type of compaction test is not suitable for very wet or very dry concrete mix, which is the compacting factor below 0.7 or above 0.98. Okay, so the apparatus consists of 2 hoppers and 1 cylinder. The hoppers have hinge door at the bottom, so the upper hopper is filled with the concrete. The bottom door then we release, and concrete will fall into the cylinder, and then we measure the compaction factor. Okay, one is wet test. Wet test, you can refer to this link to see how we conduct the test. Okay, for standard slump cone is placed in a cylinder, and then the slump cone is filled with standard manners, removal and this chip rider in place on top of the concrete. Compaction is achieved using vibration table and assumed to be complete when the transparent rider is totally covered with concrete. Based on standard BS 181, it means that for concrete having aggregate maximum size up to 40 mm only, this apparatus is basically expensive and normally suitable for precast concrete in the industry or ready mixed concrete plants. The time of vibration is considered a wave degree. The longer the time of vibration, the lower its workability. Okay, so basically that's all for fresh concrete. For next topic will be the third part of the concrete chapter, which is on the hardened concrete. Okay, so for that, thank you very much.